We need to know the definition of a vector and a scalar. So a vector quantity is a physical quantity, just something we can measure, which has both magnitude and direction. As opposed to a scalar quantity, which is also a physical quantity, something we can measure, with only magnitude. Now the word magnitude really means size. And what you're going to do now is you're going to take a look at what are some examples of various things that only have got size. So length, if you measure the length of a rope, it doesn't matter what direction the length of the rope is in, it is going to be, let's say, a 2-meter rope. Time has no direction, or rather it's always going forwards. We haven't really worked out how to make it go backwards. So time is going to have no direction. It is just, for example, 37 seconds. Speed in meters per second or in kilometers per hour. If you look at the speed on a car or on a bicycle, you will get a value. Doesn't matter if you're turning a corner, you're at 17 kilometers per hour, and it doesn't matter what direction you're going in. Distance, very much like length. You can measure the distance, and at the end of running, you have run a distance of 5 kilometers. It really doesn't matter what direction you ran in. Energy is another value that has only size. There's no direction associated with energy. Contrast with that the fact that you have physical quantities which have both size and direction. So these are things like displacement. Displacement is a body's change in position in space. So if I were, for example, to run and go on a nice long run from home and come back again, I might have run, let's say, 5 kilometers. But my displacement is 0 because I landed up at exactly the same place as I started. Suddenly, the direction that I moved in has got some bearing on what the outcome is. We all know that weight always acts downwards towards the earth, and so there is a direction. Weight is a force with a downward direction. You all know that forces could either be push or they could be a pull force. But the point is that the direction of that force becomes very important. For example, if you are stuck in a swimming pool and somebody gives you a force pushing you back into the pool, you could drown, whilst if somebody pulls you, you could survive. Very big difference. The direction becomes important. Velocity is simply your speed with the direction associated, and acceleration is the rate of change of velocity, and it also has a direction associated with it. This is just a little cartoon to remind us that if this chap were to move 2 meters back, that wouldn't be a problem, but if he were to move 2 meters forwards, he would fall off the cliff, and therefore looking at the direction becomes important. Up till now, we've only ever looked at the magnitude of any measurement. So let's look at displacement. Displacement is a body's change of position in space. In other words, if I go on a windy road, that arrow has just moved, let us say, 40 centimeters. But between the first position A and this section, position B, that's maybe only 15 centimeters. Here is a question to try and illustrate that. The radius of a circular track is 40 meters. A cyclist cycles halfway around the track. What is the distance he has cycled and what is his displacement? So he goes from A until he gets to B. His distance is half the circumference of that circle. So distance is equal to half 2 pi r, and I substitute in the radius and get a distance value. His displacement is the change in position from A to B. So that is exactly 40 plus 40, which is going to be 80 meters. And in this story, in what direction? Towards the left-hand side. When we are going to draw our own directions, we need to measure from a vertical reference line in a clockwise direction. So you have got 3 different directions to measure and 4 different ways of saying this measurement. So we've got a length. In what direction? Well, if I were to consider that this is north, this is south, east, and west, get ourselves a compass grid, and you land up with either saying this is 100 degrees east, I'm going towards the east of north, or when I'm talking about east of north, there is a shorthand way. That is a convention, and we call it a bearing of 100 degrees. I could also say I am going south from the east line, 10 degrees. 100 minus 90 is 10. 10 degrees south of east. Or I can say I'm going to start at the east line, and then I'm going to go 10 degrees towards the south line. Or I could say, starting at the south line, I'm going to go 80 degrees east of south, going from south, east of, and I go 80 degrees in that direction. That's 4 different ways of saying exactly the same. When I draw a graphical, means I'm drawing representation of a vector, it is represented using an arrow. If you think about it, whenever you want to show direction, you always use arrows, so it makes sense that you would use an arrow to represent a vector. The length of the line represents the magnitude, size of the vector. It's not always true. Let's say I'm doing a 4-kilometer line. I can't actually draw 4 kilometers on paper, but I can do 4 centimeters and write on it 4 kilometers. I would also need to say a scale where 1 centimeter represents 1 kilometer. The arrowhead always tells me which direction I'm going in, so in this case I'm going towards the east. All vectors must be drawn accurately to a stated scale, and it's ideal to say represents because 1 centimeter does not equal 1 kilometer, in the same way as 1 rand does not equal 1,000 rand. Vector diagrams must be neat and they must be accurate. They are drawn with a sharp pencil using a ruler. So, here are 4 vectors that you need to try and draw on your own, and once you press pause, once you have completed them, take a look at the answers that follow. Before looking at the answers, make sure that you have made an effort to draw all 4 of these vectors first. As you can see, if I've got 600 meters, I can say that 60 millimeters is a 6 centimeter line. So I'm going to make my scale for every 1 centimeter represents 100 meters. I would draw a 6 centimeter line, and in what direction? On a bearing from the bearing line, which is always a north-south line, around 190 degrees. The next one, I am going to choose a scale of 1 centimeter, represents 10 meters. So this is going to be a 5.5 centimeter line or a 55 millimeter line. Again, I start on my bearing line and I go 113 degrees away from that. Here I've got 25 meters being represented by 1 centimeter. That means that I would land up with a 7 centimeter line. That seems reasonable. We always want to fill up about a third of a page with our diagram. So 7 centimeters would do that. I start on my west line. I go 35 degrees towards the north, and then I draw a 7 centimeter line. 10 millimeters represents, or 1 centimeter represents 25 meters. 25 times 7, 175. Last one, we're going to go and say for every 2 kilometers that will be 1 centimeter. Because I'm going for 12 kilometers, 12 divided by 2 gives me 6 centimeters. I draw a 6 centimeter line and I start on my south line and I measure 12 degrees towards the west, and I get 12 degrees west of south.